So we talked about how we create life. Now we will just see the examples of what happens on Earth. So we talked about these all kind of life. Now the first thing we can see is the viruses and bacteria. So these are the microscopic creatures that we don't see or touch with our own hands, but they are ecologically important because they are decomposers. So they decompose every creature that dies, and they also create illnesses, as we very well know. In the past 2 years, they can also create pandemics. So, but these are more like vectors that we use. So when we create an organic material, yes, it is affected by viruses and bacteria, but as you very well know, virus is also a computer term. So these kind of disruptive or helper life forms can also exist on other
Hocam,
ecosystems. Yes.
are you sharing your screen right now?
Am I, or am I not?
Yeah.
No,
Yes.
I am not.
Yes, I can see.
Okay.
Oh, I'm sharing it as part of my virtual cam. So right now you can see it better, right?
Yes, okay.
Okay, great. I put my screen up on my webcam, so you can see my webcam, but you couldn't see my screen. This is higher resolution. This is better. Thank you. So in our game terms, viruses and bacteria can be the creatures that we don't see but affect our gameplay in some way. Or, for example, in Star Wars, we have the little creatures called midichlorians. They are some form of bacteria that are inside the cell, and they help you connect with the Force. So they are basically the USB connection you have with the Force. And effectively, for example, in Star Wars, the midichlorian kind of dispels the magic a little bit, because it isn't like everyone can do it. It is like certain individuals with very high counts of midichlorians in their blood can do it. So it basically boils down to the Skywalkers. But what we consider is, for example, viruses are not exactly alive because they are some form of sheath with a DNA code inside and some means to attach to a body. So they don't satisfy the life criteria that the scientists define, because only when they attach to a cell and they release their DNA is that when they do their work. And those cells replicate this DNA and break their own functions and just spread. But we don't care about this, whether they are alive or not, because in our design, what we care is that they are some form of vector to transmit something, to create an effect. So, for example, what is the difference between bacteria and virus for us as humans? There is no difference. The difference is that we have to take two different kinds of medicine to combat these disease vectors. So this effectively creates two kinds of items in the game. For example, one can be a red pill and one can be a blue pill to fight two different enemies, for example. Or you can, in your game, create a third type that requires a third kind of resource, for example. So basically, viruses and bacteria can be there, but we don't have to see it. If we have illnesses, for example, in Far Cry 2, you can contract malaria, and you have to take a pill in the middle of combat sometimes to combat the dizziness that it creates. So it affects the gameplay. It affects your, it disrupts the way you play, but it is designed to be so. So they created an illness inside the game, which also has a counterpart in real life, to affect the way you play the game. So they used viruses and bacteria to create a gameplay mechanic. We have fungi. These are basically the mushrooms and yeasts. And they are decomposers. They reproduce by spores, and they don't do photosynthesis. For example, these by themselves are not very interesting. They are basically used for herbalism, for example, in lots of games. If you create a herbalist character in Skyrim, or herbalism also is important in Witcher, when you collect ingredients for your potions. Or in World of Warcraft, you can collect certain items as well for recipes. So other than that, it seems they don't have any use. But you can also get very creative. There is a very good example here. And these are orcs, as you probably very well recognize. But do you know what connection they have to fungi? Does anyone know? These are Warhammer 4K, 40K orcs, and as you can see, they are driving vehicles and such. So these guys are basically fungi. So they grow out of spores. They are not born. They are not mammals. So they are spores, and they grow into a full-blown orc over time. And why does it matter? It's a very important, a very interesting lore for the game, for the universe. But also, it creates a very interesting thing, because whenever people defeat orcs, they have to go in and burn the entire area down to destroy every single cell or every single spore that was left there. Because if you don't burn the entire area, if you don't scorch everything that's there, you might leave just a tiny little spore of orc, and then you soon will have another orc problem. For example, this is a very interesting design decision. These guys don't look like fungi, and they move about, and they are not plants, but the way they reproduce is designed as with spores. So now we don't see an organism of this complexity coming out of a spore, but it doesn't mean it cannot happen. So this is a very interesting design choice, for example. And then we have plants. Now, I will skim over this rather fast, because there are lots of details, but we don't need them. But basically, plants are divided into 4 categories. They are bryophytes, moss and lichen, the small, very small things. There are seedless vascular plants like the ferns, and gymnosperms, seeds with no fruits. These are, for example, pine cones and other trees. And there are flowering plants, which are important for us because they bear fruit. And you can go very creative about this. You can create all kinds of different plants, and you can create uses for them. And that is actually what we care about. What kind of a use can we create for our plants? So basically, there is a root and stem structure and leaves for photosynthesis, for example. These are called root and shoot system. This is what we see. But for some items, for example, some plants, the root is important as a food source or an ingredient. But basically, when we design plants, we of course have cosmetic ideas that we want our world to look like. But basically, we use flowering plants for food, as in rice or wheat or corn, or we use them as industrial materials like cotton or linen. And this, in turn, affects what kind of materials our species use, as we will see in the following lessons. When we create intelligent species and when we create cultures, the kind of plants that they have access to will kind of determine their diet, their type of behavior, their values, and other stuff. And we also talked about this in the animals, in life cycles and diets. So what animals have around them will be what they eat or what they use. So this is why we think about the plants and how we can use them. And when we look into plants further, for example, we can see the fruits. And again, why is this important? These are mainly important for cosmetic reasons for our game. But for example, in Dark Sun, again, one of my favorite D&D worlds, fruits have an important place because in dark sun it is very, very hot and it is very difficult to come across liquids. This includes potions. So you don't have potion of health in dark sun, for example, because a vial can break very easily and the contents can spill. And even then, the contents can just evaporate if you leave them out in the open. Instead, for example, you have an apple of health. So you eat an apple and it heals you. And these are magically grown in trees. And yes, they don't like magic in dark sun, but these somehow exist because they have a reasonable excuse for that. So in dark sun, fruits are important because most of the time they have magical abilities that will help you, like a potion. So how much water they can get or how they are used it's a different thing, but fruits have an important place. So we can design fruits for dark sun, for example. And then we have trees, also a very important piece of any ecosystem. But for example, when you are in an RPG game, you see trees and generally you don't look around to see what kind of trees they are. Are they deciduous? Do they fall their leaves? Or are they evergreen that always keep their leaves? Because if there are seasons in the world, in the game, maybe some trees should fall their leaves and some should not. So let me just switch this. Why can't I switch it? Okay. So for example, when we look at these, we see that deciduous trees, they fall their leaves to prevent water loss in winter. So they see them in areas where rainfall differs seasonally. So where if it's an area that is always with rain, they may not need to shed their leaves at all. But if it has a harsh summer, very hot summer and winter, they might drop their leaves in the winter so they won't lose any water over the cold. And they generally have flowering plants and they are kind of hardwood, but this isn't very important. I mean, hardwood doesn't mean they are going to be hard. It's just a classification. For example, this is balsa tree. Balsa tree is used to make models and it's technically hardwood, but it is very, very soft. It breaks very easily. But for example, you can decide what kind of weapons you can make with them. If they are used for good bows, so your tribes living in that certain area can use those trees for bows, so they are good bow makers. Or if they are going to be completely destroyed by another tribe that makes better bows, for example. And evergreen trees, they don't fall their leaves. So kind of like pine trees, and they are seen in taigas. Taigas are frozen tundra forest areas, and they generally produce softwood. And again, as I said, it doesn't very much mean anything. And then we have tropical trees. Tropical trees are evergreen. They create a canopy over the forest, so they kind of create this giant cover over the entire forest. So much so that sometimes there are some areas that don't get any light at all in the forest ground, for example. There is no light coming here. So, and for example, in tropical areas, there is always lots of things. If you look at this, the density of plants in here, they are always competing for nutrients, for sunlight, for growing space. So it's a jungle out there, basically. And it's a very tough environment. Evolution is in full swing. So the animals are generally matching that. So that's why tropical areas are generally very dangerous. Everything is out there to kill you because everything is trying not to die. And there are, interestingly, also types of trees that stay alive by clinging on big other trees. They are basically parasites. They are trees, but they are like vines. So we can design our biomes around these, for example. We can think of what kind of trees or plant life we are going to have, and then we can go on to animals. And when we think about animals, we mostly think about systems. Plants also have systems, but in animals, these are more prominent. So we can have a cover system that is a skin, hair, nails, skeleton, muscles, nervous system, and their endocrine system, circulation system, respiration, digestive, excretion, and reproduction. Now, we don't have to take all of these into account, but there are certain ones that will affect how we design our animals. Mostly the cover system will be important, skeletal and muscle. Nervous system will be very important, as you will see now. And in reproduction system, digestive system, these can decide some behaviors of the animals, for example. And all of these systems work to create the homeostasis of the animal, to keep the animal alive, basically. Because without the balance of the homeostasis, we don't have life. So, what kind of animals are we talking about here? These are just examples that we have on Earth, by the way. We don't have to create a class of these animals, but I'm not putting any pictures up here because there might be some of you that are disturbed by certain animal images. So we have arthropods. These are basically centipedes and millipedes and other stuff. So I'll just draw a representation. They are basically these guys. They have appendages, means their bodies are in segments. And for example, in centipedes or millipedes, each segment has a pair of legs. They actually have 40 legs because of that. Well, they have an exoskeleton system, and they may grow out of it. And they have compound eyes. We will come to this later. So scorpion is an example. Centipede and millipede are an example. But crabs are also an example. So crabs, as you know, these side-walking guys with tiny eyes and such. These can be very harmless little creatures, or we can make giant versions of them that the player has to defeat, for example. This is some kind of animal that we can encounter. And we have arachnids, and these are very famously spiders, which a lot more people are afraid of, and some people are phobic about. So they have 6 pairs of appendages in their bodies. So the 2 are the teeth. They are actually moving about. And the second part are the pincers. And there are 4 pairs of legs. This is not a spider, this is an ant, sorry. Like this, yeah. But for example, a spider is important because it produces silk. Well, Spider-Man also can produce silk in certain movies. We have bugs. So bugs have basic body sections. There is a head section where the antenna and the eyes reside. And there is a thorax, central section, where the wings come out of and the legs come out of, and the abdomen that has the organs. So why is this important? I mean, why do we care? Because when we are designing something like this, knowing what happens in our world can help us create more believable animals. So if you don't put legs here, well, there can be legs there, of course, but it creates that familiarity that we spoke about at the beginning of the lecture. So when we see an animal, our brain tries to match it with something we know about to create that familiarity. So even if we are creating something totally new, knowing this stuff helps us create believable animals. Or if we are going to break the rules, we can break them by knowing what we are breaking. So these guys have trachea respiration. So it basically means they have holes around the sides of them that goes directly into their cells. We will talk about this later. 6 legs and very high adaptability. Okay, for example, cockroaches don't die in radiation. And bugs also have a metamorphosis stage. And if it's a no metamorphosis, it grows to a young from the egg, it grows up and becomes an adult. If it has an incomplete metamorphosis, it turns into a nymph from an egg. This is generally the form that doesn't have wings, for example. it's a modified young state. This is basically a small version of the adult, the young, the baby, like us humans. We don't have metamorphosis. But for example, if we had wings, and if we could produce the wings only after we are 18, for example, we would be an incomplete metamorphosis. So we would be nymphs first, and then turn into adults. Now, a complete metamorphosis generally has multiple stages of animals that look completely different to each other. So an egg becomes a larva first, and then it turns into a pupa. It produces a cocoon around itself, and then it emerges as an adult, as we see in the butterflies. So this brings the notion that Pokemon don't evolve, they go into a metamorphosis. So, for example, this is a pet peeve of mine. I hate the word evolve when it comes to Pokemon because they don't evolve. Evolution is something that a species does. So dogs have evolved, for example, from wolves into dogs, or cats have evolved from wild cats into domestic cats as a species. But a cat itself doesn't evolve into something else. So Pokemon don't evolve. They undergo certain stages of metamorphosis and create other creatures, turn into other creatures. But it's not evolution. But since evolution is a very popular term, they used evolution for them and it's stuck. But, well, let's put that aside. There are very interesting ways to use this, for example, as we see in StarCraft. In StarCraft, the species of Zerg starts their life as a larva, and it has actually all of the genetical imprints of the species. But you, as the hive mind, decide what this will metamorph into, what it will morph into. It can morph into a hydralisk that can throw spikes and moves fast, or it can morph into an ultralisk that moves slow, only has melee attacks, but is very big. I mean, you see another human-sized creature here, a zealot, and it is very big, very slow, but it has a very high damage output. This is, for example, a decision you make as the player. You decide what this Zerg larva evolve. I'm very sorry, it doesn't evolve into anything. It metamorphs. It morphs into something. But when they designed this Zerg as a species, for example, there's a backstory. So Zerg organisms, there is also a kind of Zerg organism that can fly, and it's something like this, very basically with a scorpion tail at the bottom and wings. I don't remember their name, but they can fly in the vacuum of space, for example. And they go to other planets. They find creatures. For example, this is actually an elephant-like, very peaceful creature. But they incorporate the DNA into their own, and they get a catalog of creatures that they can morph into from larvae state, and they of course make modifications to that to be more aggressive. So this is actually a peaceful creature that turned into a behemoth of destruction in the Zerg's hands. So, for example, this is a very interesting case for how you can use metamorphosis in a game, because in StarCraft you have an asymmetric game mode. You probably all know about this, but you have Terrans, and you have Protoss, and you have Zerg. Terrans can create fast units with low cost, not very strong individual units, but they can create a large group. In Protoss, you have more expensive units that are also more durable and more damaging. And in Zerg, you have small units that can morph into lots of different things depending on what you need. But these can create a better hive, and these can create better defenses. So they are asymmetrical. They don't have the same gameplay at all. But for the Zerg, they designed something like this, and it is actually very creative. So we also have fish. We have two types of fish, cartilaginous and bony. So the fish that we eat mostly have bones. We call them kılçık, but they are bones basically. But this is very interesting. For example, there are sharks and rays in this, and sharks, for example, have to swim continuously to be able to breathe. We will see this later. It's because of their structure. Now, when we talk about fish and sea life, this is from the game Subnautica, for example. You can see how these are designed. This is, for example, a peeper, and it has a very large central eye here, and it can see very well. And, for example, but its eye gives it away. So in low light conditions, it shuts its eye so that it isn't seen. And this is a very interesting fish. It is designed as it's kind of it propels itself by, it doesn't have a swimming structure like this. It cannot swim by using its fins, but it changes the water density in front of it, so it slides into that space. So it creates, basically, this is the fish, and this is the front of the fish, for example. It lowers the water density in this area, so it creates some kind of flow of current into this area and flows there. Now, the designers in Subnautica didn't have to do this, for example. They could just call it a normal fish. But it's a very interesting piece of read inside the game, and you take a different take, for example. And this is an arthropod or blah blah pod, and as you can see from the design, you can guess what it does. It releases toxic gases from its back to protect its youth, and itself is immune. And as you can see, the design team very interestingly gave it a gas mask.
Sure.
Can you still take me?
Yeah.
Okay.
Right. It's good.
Okay, it says the connection is unstable for a minute there. So this is very cleverly designed like a gas mask. So what is the chances of an animal in a very foreign, unknown planet to have a face for a gas mask and produce gas, for example? This is a design decision. This is an interesting design decision, and it actually speaks to the player. It may not be very plausible because it really looks like a gas mask with the eyes and all. It's as if this kind of animal just put a gas mask on. So it's a design decision made by the designers to create that sense of familiarity, maybe also as an inside joke. And this is, for example, a Reaper Leviathan. And when you look at it, it's very big, by the way. You can see that it is predatory. You can see the intention in the design from the placement of the eyes and the giant pincers at the front. And it's a really scary experience to see this for the first time. And then, for example, we have amphibians. Amphibians are toads and frogs and salamanders. They can live on land and in water, for example. That is an interesting capability to live in more than one environment. And not just different biomes. I mean, you can both live in snowy areas or in tropic climates, nothing like that. The very nature of the environment is different. One has water as the surrounding element and one as air. So it is very different, really. And then we have another favorite, lizards. You can just put scales on anything and call it a lizard template. So they live on land. Tortoises are lizards, not to be confused by turtles. In Turkish, they are all kaplumbağa and tosbağa. I mean, tosbağa is the tortoise, I guess. But turtles live in water, so they are basically sea turtles, amphibians. Tortoise lives on land. And there are lizards, snakes, and crocodiles. The interesting thing about lizards is that they are ectothermic, so they are cold-blooded. So there are some animals that are endothermic. They produce their own body heat inside themselves, like this. And then there are ectothermic animals that have to take their heat from the outside to sustain their body temperature, to create that homeostasis that I speak about. So for example, if lizards, when they're out in the sun, have to go someplace, find a shade to hide under, because if they stay out in the sun too long and they intake too much energy, their blood starts to boil, their body temperature rises beyond what they can sustain their homeostasis with. And then we have birds. They have scaled legs like lizards, and they are flying, maybe flightless, like penguins, for example. But they are adapted to fly. They have hollow bones, melded joints, so their body is more rigid, better for flying. They have no teeth because it is heavy. Teeth cause heavy. They have beaks instead, and they have their lungs spread around the body because they need lots and lots of air. Oh, I have lost this connection. Let me just turn this off and put it back on. Let's see if we can connect with that. Apparently not. Just see if I'm on the same thing here. Yes, I am, but it doesn't work. Okay. Doesn't matter. So, and then we have mammals. They have hair, they produce milk, they have various kinds of teeth, incisor, cuspid, and molar. I mean, these are all things that we will consider when we design our animals. But again, these are design decisions that we will make based on our gameplay mechanics and other stuff. They have various reproduction styles. Now, when we come to the systems themselves, these are the parts that we will think, because the approach your players will have towards an animal will change based on whether it has a human-like skin, scales, or lizard scales. It again says my internet connection is unstable. I hope you can get this properly. You can see this. So we can have fur or hair, we can have fish scales, we can have lizard scales, or we can have skin. These kind of create a template for us. And then we have skeletal systems. For example, there are very interesting things here. As you can see, in a crocodile, we have legs protruding out from the sides. But in cow, it's upright. And in fish, we just have cartilages going up to the fins. But for example, in chicken, we have a curvy neck like this. And this is used in a dragon, for example, in a dragon's skeletal system. But the legs are upright, rather like a cow. And wings have a totally different structure than what we see here. But we can see that this design somehow imitates the skeletal system of the animals we know. And that makes sense, again, because it creates the familiarity and it creates the believability. So when we have a neck system like this, or a rib cage, rather like the big animals that we know, and the bulging, for example, and you see this, let me just try to pop this up again. Yes, I can now. Just a second. It is very, just try this. Okay, interesting. No, it breaks apart really easily. I'll just put this aside. Sorry about that. So, but for example, the bulge you see here is similar to this, but afterwards you see the lean structure of, for example, a dog or a cat. So this is an aggressive hunting animal, so it's very lean, but a cow is not like that. And when we look at the muscle system as well, for example, it is designed so that it will have some resemblance with real life. So you have dorsal muscles here, for example, and in a horse as well. And when you look at the structure, it makes sense because it takes reference from real life, and that in turn makes this believable. For example, taking a horse's neck here would not make sense. This is more like a goose neck, because horses have muscle systems so that it keeps the neck upright, and when you push their head down, their muscles pull it back automatically. So they have to use force to push their neck down, but it comes back up by itself. So their muscle system has evolved so that they could keep their necks up without any effort. Now you cannot use this here on a dragon because you need a winding neck that can look at any direction, but the rest of the body makes a lot of sense, for example, with regards to that. And then we have the nervous system. This is important because sensors are in the nervous system. So what kind of sensors can a creature have? We have the extroceptors. These are the external sensors like the eyes or the ears or the nose. And we have proprioceptors. These are the sensors in the body that tells us where our limbs are, for example. Because when you lift your arm up and close your eyes, you know where your arm is. It's in front of you, lifted up. And you know this because the internal sensors, the position sensors in your body, feed that information to your brain. And then we have the internal sensors, the ones that, for example, give the signal to the brain that you are hungry or that you are sleepy. And what we care more about is the sensors by stimuli, because we can have mechanical sensors like our skin. It can sense contact. We can have chemical sensors like our nose and tongues. They basically sense the chemicals that are around us. It can be a light sensor like our eyes. It can be a thermal sensor like our skins again, and it can be an electrical sensor. We don't have electrical sensors, but sharks do, for example. Sharks can sense creatures kilometers away from the electrical field that their body produces. That is very interesting. So we are not limited to all these. We can create all kinds of other sensor types that sense different things. We can create a creature, for example, that senses electromagnetism and attacks the player, for example, if the player turns on the radio or opens any electronic device. This is just an idea. But we have seen games, for example, where certain animals or creatures can only detect sound, or others that can only detect motion. So when we look at the eyes, which are very important for our design, we have the point eye. This is just a point on the body that is actually a light detector. Very underdeveloped animals, creatures have this actually, but we are more interested in a normal eye, like these eyes over here, and the compound eye, which I'm not showing because some people are disturbed by that, but you can think of it as the small little hexagon eye system that a fly would have. I think we are back on track here. Yes, we are, but with very high latency. So a compound eye system is something like this. And as you can see, a normal eye has a low FPS. So our eyes, for example, are around 45 to 53. Of course, when we pay attention and when we focus, we can increase our FPS in our eyes up to 500. But this is for a very short time, and when you focus very well, it was a test, a research done with fighter pilots in the British Navy, Air Forces. So after World War II, or maybe during World War II, they showed pilots very fast pictures of enemy planes or friendly planes, and they have found out that pilots can tell the type of plane with an FPS of within a time frame of 1/500th of a second. So this basically makes the eye see at 500 FPS. But this is a very special occasion. Basically, normal eyes create good picture reproduction in our brain, and they are at front for the predators because it creates depth perception in that area. And in herbivores, they are on the sides because herbivores always need to be on the lookout for predators, so they have to see what's around everywhere around them, if possible 360 degrees. So for example, horses have a very small 3D view at the front here, but cats have a better 3D view at the front of them. And we are also in the predator class, so we have both our eyes in front of us. So we have a limited peripheral vision, nothing like this guy here, but we have 3D vision. A compound eye, the kind that we find of flies and insects, they have very high FPS, they are very good at detecting motion, but they cannot reproduce pictures very faithfully, and we could see why, because they are basically a group of very small light detectors. So in night hunters we have vertical pupils like this. This limits the amount of light during the day, and it enlarges during the night. So if you have cats, you know when it's evening their eyes enlarge to take in more light. And so the vertical pupils create better sight at low light, and since they are vertical, they create better depth perception. So because these night hunters generally have to pounce on their prey, and they have to measure distance very accurately. If they pounce too back or too forward onto their prey, they might lose. So day hunters, for example, have round pupils all the time. It's adjusted for lots of light intake, and when they don't need very high depth perception. For example, lions have round pupils, unlike some other cats, because they are day hunters, they don't hunt at night, and they also hunt in packs, so they don't need to stealthily approach their prey and then pounce on them. And herbivores have horizontal pupils because they need to detect horizontal movement. They don't need to detect vertical movement. Actually, it is better because it limits the amount of light coming from below and above, so they can concentrate on what's happening all around them. And for example, these are different hunter eyes. This is a gazelle. As you can see, it's a horizontal eye here, and this is a probe, it's also horizontal. And interestingly, for example, as this sheep lowers its head, the eye is still horizontal. It doesn't go like this. So it keeps scanning the horizon even when its head is down. Okay, so what about the respiration? We can have respiration through body surface. It all generally occurs on animals with low metabolism when you don't need that much amount of air, and they have to be small animals, so they have high surface to volume ratio, so that the amount of air they get through their skin is enough. And to effectively get this air through their skin, they need moist or wet skin. So this means mostly, for example, amphibians. We can have trachea respiration. It is where basically the no, I still don't have it. Basically, the animal has small airways into their cells, and the air goes directly into cells. So it's not lungs. I made a typo here. So it generates a very high metabolism potential because you get the air directly into the cells. And basically, animals that have trachea respiration don't have any growth limitations. So you can see very large bugs in warm climates, for example, or for example, in dark sun, you can have bugs as mounts, insects, because they can grow to human size or even more. Gills allow underwater breathing. Lungs generate breathing by diaphragm. They are highly developed in birds because they need lots of air. And there's something, I'm really sorry. There's something called book lungs in spiders. So moving on to digestive systems, this generally concerns us about what they eat, the food chain, and we don't really care about what happens inside the animal, digestive related, but what animals they eat may be important, for example. Now, when the reproduction system, we talked about this, we can have sexual reproduction, placental reproduction, for example, what we have as humans or other mammals. They can be using sex like kangaroos or eggs like platypus. And we talked about asexual reproduction as well. And this all comes down to actually the behavior that the animal will have, because depending on whether they are a herbivore or a hunter, grazer, they can have a social structure of a herd, or they can be loners, or they can have a hive mind, like bees, for example. This may dictate where they will appear in our world, on our game, and how they will behave when we encounter them. Their behavior may be hunter or grazer, for example. They can have a social hierarchy. For example, you can have a herd of animals that you have to attack, and when you attack one of them, the entire herd will come towards you, or just the leader will charge at you to protect the herd, for example. And you can have territorialism, whether the animals try to protect their territory, which may be very important in games, because, for example, in some games you have neutral animals that don't do anything unless you attack them. And then you have hostile animals that attack you as soon as you get into range. You can think that these attacking animals are territorialist animals, and they want to defend their territory against any invader. And then there is sexual selection among animals, which creates modifications. So you see the lions have manes and the females don't, because they want to attract the female. And in nature, actually, we see normally that males have the modifications. Males have the colorful feathers that try to attract the females. Males have the large mane that tries to attract the females. So in nature, we see generally that females are the more plain types of the species, and the males are the ones that try to show themselves with these kind of extra bits and modifications and stuff. And how they care for their young is also going to be important in this aspect. Let me just check my notes here. So this is actually what we're going to consider. Then if we look at some animals, for example, from world mythology, this is a griffin. It has the hinds of a lion and the front side of an eagle. Both are regarded as highly noble creatures, for example. So the griffin is a creature of good, nobility, and it creates a sense of heroism. And it's mainly because of the animals that is associated with. This is, I think, a hippogriff. The main difference is that the hinge of it is a horse, for example. And we would see that, we would conclude that hippogriff is a better mount than the griffin, because it is a horse. It's part horse. It should be a better mount. Or here we have a chimera, for example. This is mainly a bad guy. It has many different heads, and every different culture has a different kind of chimera, but this is a dragon, a goat, a snake, and a lion. They are all predators and attackers, so they are regarded as such. But, for example, if we go into, these are, by the way, hybrids. And from world mythology has lots of hybrid animals because people in the past decided to work with what they saw in nature. And here we have the creatures, for example, from the D&D campaign books. This is, for example, you can see that this is a brainy creature. It must be very intelligent, and it has tentacles, so it's probably flying, and it's probably flying with brain power. So when you see this creature, you can kind of sense the kind of thing that you are getting into. It's going to attack you magically or psionically, for example, because it doesn't have any attacking features from what you see. So you will have to defeat it in some magical way. This is a behir. It has, 12 or 14 legs, and it can turn you into stone. This is a gorgon. It can also turn you into stone, and it breathes poison, blah, blah. And for example, this is a seahorse in the literal sense. This is a gelatinous cube. It is a cube of gel, and if it's a dungeon monster basically that you can walk into because it's crystal clear and it's transparent, but it starts to digest you slowly. This is, for example, another intelligent creature. This is a piercer. This is very interesting. They drew the eye on it just to make it look like a monster because it actually doesn't have an eye. And what it does is it senses heat. So when you walk under it, it drops itself on you, hopefully impaling you and killing you in the process. Then it starts digesting you slowly, and it does this. It needs to feed once every few weeks because it has a very slow metabolism. And then it starts slowly to climb back up and comes back to its original place and starts waiting again. So for example, this one has a thermal sensor. It doesn't have a light sensor. It is found in dark caves and areas. I don't remember this guy, but you can see that it is a hybrid between a tiger, a goat. It has 6 legs at least, maybe 8, and it has a barbed tail, so it is a predatory animal, but as far as I remember, it is intelligent, so you can reason with it. So anyway, these are all different animals created. The Gorgon is actually in Greek mythology, I believe, but the others are created from scratch, but by mixing some elements. So what I want to show you now is a scene from Subnautica. I hope you can watch it properly. Now, Subnautica is wonderful in terms of biome generation. So let's start from, I want to show you everything, of course, but so this is a very well creation of an ecosystem. So when you explore in Subnautica, you can see everything has a place. Everything has a function in that ecosystem. Even if you don't know the immediate function of it, you sense that it has something to do. So for example, you find quartz, an important source within these corals, and you can kind of deduce that that's where they grow because there's some important element, there's something that makes them grow there. So you gather resources based on some areas, and all these fish that you see, the way they swim around and the way they interact with each other, you get the sense that you are inside an ecosystem here. And these are the gasopods. Now I'll just fast forward a little here. This is one of my favorite locations. For example, these are floaters that keep the rocks floating inside the water because they lift them up because they are full of air themselves. Just a small creature idea. And when you come here, the tone changes very much, not just the color, the tone of the biome changes dramatically. You sense this is a hostile place, for example. Somebody's been here before, it's in the story.
In this cave support a microcosm of unique, possibly predatory life forms. Detecting an artificial structure somewhere in the region.
Also, the game has wonderful sound design. Subnautica is basically an horror game, actually. It's an exploration game, but you get scared out so many times. So this is another part that I like. One of my favorite biomes, definitely. So you can see all the details in plant life here and the animal life. So these apparently cling to the mushroom bodies for sustenance, like in a rainforest, a jungle. And there are other
In this area is
plant
dominated by
life.
plant life, picking up faint or terra vehicle signatures.
And let me just see another point. For example, there is a floating island somewhere in the region, and these are the giant versions of the small floaters that I showed you earlier. These are the ones that could grow so much that they could lift the entire island to the surface. So this is an advanced stage of that life form, for example, and that's a very nice touch. You see the same structure around here as well, for example, these guys. And this, for example, creates two layers for this area in the map. This is the upper layer of the map, the surface, and then there's a lower layer of the map. This is a very nice region. So we go underground to a lower layer in the map, and we come to a river inside the sea. Now this actually happens in real world. So this liquid here has a much higher density, so it sinks to the ground. But for example, you see that the ecosystem here is very different than the one above. And you get that feeling, that is the important part. You may not have much use for this animal, for example, other than it's attacking you. And this is a very scary guy here. And there's something else. Here it is. For example, this is the other type of biome that you might encounter. Here it is. Now let's just see if there are spoilers there. Let's go over here. For example, you have all those green and purple colors, and then when you go deeper, you come to an area where it is covered by lava. So you have a red biome all of a sudden. And you see these fish also have variants up in other biomes, but these are variants, they are not the same. They didn't just take the same fish and put it in here, they modified it so it would be better suited for this biome, and they put these boomerang fish. They also exist here, but they are a different type of boomerang fish. So in this regard, Subnautica is a wonderful representation of what an ecosystem could be inside a game. Okay, so just let me switch, and no, I want to press some buttons. I want to stop my screen share. Okay, so that concludes this week's lesson, which was quite a bit long, I'm aware, but once we get over this stuff, now next week we will get to the interesting bit. We will start designing our intelligent species that will matter inside the game by using these guidelines. So now it will matter whether our species is tall or has scales or has claws or eyes, or they are just very big, gentle creatures that we interact with. So this is, for example, when it will come into play in Stellaris. What species do we see in front of us, and what kind of features do they have, and what kind of features that we see play into tropes in our heads that will give us an idea about what kind of creatures they are, for example. Okay. Thanks for listening. See you next week.